Hello friends, welcome back. Today we're going to never mutate state. These final challenges describe several methods of enforcing the key principle of state immutability in Redux. Immutable state means that you never modify the state directly. Instead, you return a new copy of the state. If you took a snapshot of a state of a Redux app over time, you would see something like state 1, state 2, state 3, state 4, and on. And so on, where each state may be similar to the last, but each is a distinct piece of data. This immutability, in fact, is what provides such features as time travel debugging that you may have heard about. Redux does not actively enforce state immutability in its stores or reducers. That responsibility falls on the programmer. Fortunately, JavaScript, especially ES6, provides several useful tools you can use to enforce the immutability of your state, whether it is a string, number, array, or object. Note that strings and numbers are primitive values and are immutable by nature. In other words, 3 is always 3. You cannot change the value of the number 3. An array or object, however, is mutable. In practice, your state will probably consist of an array or object, as these are useful data structures for representing many types of information. There is a store and reducer in the code. Okay, so let's look down here. The store is usually at the bottom. I'm going to open this up so it's easier to read. There is a store and reducer. So here's our store, and we have an immutable reducer. And so here's our reducer. Finish writing the add to do case in the reducer to append a new to-do date to do to the state. Don't mutate the state here, or the test will fail. Okay, so we've got our to-dos here. Our default state is the to-dos, and so what we want to do is pass in a new variable. There are a few ways to accomplish this. With standard JavaScript or ES6, see if you can find a way to return a new array within the item from action.todo append to the end. Okay, so I think what we could say is we could say let new list equal to-dos. I forget, what's that called? The I can't remember what that operator is, but new list is now to-dos, and then we can say new list dot, what do we want to do? Don't mutate state here or the tests will fail. New list, we want to do add to do. Okay, so we could do dot push and then action dot to do. And then we return the new list. I wonder if that would do it. Okay, that did it. So what I'm basically doing with this guy is I'm duplicating it. New list is equal to the to-dos, a duplicate copy of the to-dos. And then the new list, what we're doing is we're adding on to that, and we're adding on the action.todo. So that goes action.todo. So whatever that is. So somewhere down the test, what they're doing is they're calling store.dispatch, and they're adding add to do, and we could make the to do something like jump, you know, be a useful programmer. And then if we were to use console.log store dot get state, is that right? Yeah, so now you can see we've got go to the store, clean the house, cook dinner, learn to code, and be a useful programmer, all in here. So what we've done is we've made a copy of the existing state, and we've added to that copy the action.todo, which in this case was to be a useful programmer, and then we've returned the new list. And that's what they mean. One thing that we would do to make this not work is if we had just gone to-dos.push action.todo. If we just did this and then returned, well, if we just returned this, I think that we'd be mutating the state and it wouldn't work. Yeah. The Redux store should exist and initialize with a state equal to to-dos array in the code editor. Dispatching an action of to-do type on the Redux store should add to the to-do list item and should not mutate state. Let's say, here we go. If we went down here and go console.log to-dos, you're going to see that the to-dos has been mutated. We don't want that to happen, right? So let's, I'll just copy this, and then I'm going to press Command-Z, and just go back to where we had done the duplicated. And now here we're console logging the state of the store, but the to-dos should not have changed. If we console log the to-dos, you'll see that they are the same. So the to-do object has not changed. The default state has not changed. It's just the state that is held within the constant. And so, yeah. I hope that makes sense. That's what they mean when they say you don't want it to be, you want the state to be the same. This is going to cause the tests not to fail, so if I delete all that stuff, I can run the test and it'll pass. Yeah, there's a lot of ways to do this. You could do this a bunch of ways. I think it's called the spread operator. The spread operator is the easiest way to do it. That's the way that I do things now when I'm coding in JavaScript, so I would recommend doing it that way. You could iterate through each element of the to-dos. You could be like, let the new list equal here, and then you could be like, for var I is equal to 0, I is less than to-dos dot length, I is plus equals 1, and then within each element, you go new list dot push to-dos at position I, right? So then you're pushing them all into the new list, and then the new list, you add the action of the to-do list, and then you get your new list. I think this would pass it as well. Instead of doing it this way, you could do a to-dos, you could do to-dos dot for each, and you could pass in a function of that to-do. You do and then the new list dot push. This is just another way to do just basically the same thing. Now we're just going to do a for each loop instead of using a for loop to get it. And I think that this would pass it as well. New list dot push to-dos at position I. Oh, we just want to pass in to do because we're passing in the parameter. We're saying for each element in here, we're setting this to the variable to do, and then we're saying new list dot push the to do. And so this one would do the same thing. And then we could make this function ES6 as well. So we could go like this. And then I think if we ran the tests, this would work as well. And I'm pretty sure we could make this a single line function like this as well. We don't need return if we do it this way. And then we would get the same thing. So this is just another way to do that for each loop. I think we could go map too, right? Yeah, map would work as well. Yeah, and so, I mean, I think if we did it this way too, to do this, we could make it a single line dot push to do. Would that work? No, okay. Something breaks in there. We could do unshift, I think, and that would make it so we add it to there as well. If we do unshift, maybe just shift. Okay, we can't do that for some reason. Yeah, but anyways, this is a bunch of different ways that you can do it. They're all pretty much the same. It's more about what you're comfortable with. This is probably the most concise way. That for loop is probably the most explicit way, so you remember how to do it if you're an early stage programmer. But yeah, I think that kind of fills in this one. Once again, we're setting a constant global variable to add to do. We're setting it to equal to a string. We have a global variable of to-dos, which represent each of the to-dos that we have existing. We're creating a reducer for our Redux store, which means that we're creating a tool in which we can pass in the state and then an action, and then within the state and the action, and that makes it so that we return a copy of the state of the object which we want to create. Here we're duplicating the array. Once again, I'm just going to bring it back to the way that I had it because I think that this is the most concise way to do's. Making a duplicate, and then we're adding the to-do. we return the new list, and then if we get something that's not an add to do, then we just return the normal state. And then down here we have our action function, or our action, it's an action function. And this is the add to do. We pass in the to do. So when we call this is like when we set the store dot dispatch, and we dispatch an add to do, and then we pass in something like a to do thing like be a useful programmer. And then if we were to store dot get state, and we need to console log this in order to see it. Now we have our be a useful programmer, and we've added that to it. And so that's what this guy does. It just returns it. It says this is the type of action that we have is add to do, and then the to do, which is equal to the parameter being passed in. And so in this example, add to do is passing in this parameter. And so that parameter gets passed into here. The add to do, we say the new list. Well, we take a copy of the to dos, and then we add our action dot to do, because we're passing it in here with our action, add to do, type to do, action dot to do. So we're adding it to the new list. We're returning the new list. So we're actually making a copy. We're not working with this variable. We're working with a duplicate piece of data that we've added the action to do list and to here. And that's why you can see that if you were to console log the to dos down here, you'll see that they don't have be a useful programmer here. So we're not mutating the to dos state. We're just duplicating it and adding it to here. And then finally, we create the store so that we can run all these Redux functions on it. So run the test. Seems to pass. Cool. Hope you guys enjoyed this one, and we'll see you in the next lesson.